Alright, so we're going to look through my final measurements that I have for my model, and this is what I'm using as my bill of materials, or to create my bill of materials for ordering parts from Masumi. So these are the measurements I got for the truck. So I have a 20-inch cabin height, a 4-inch cabin clearance, a 17-inch bed height, a 65-inch, this should be 60. A 60-inch inner width, so this is going to be from trim to trim. Essentially, this is where I want my extrusion to fall just outside of, if that makes sense. So like my trim is not in the 60 inches, it's right outside of the 60 inches. So this is going to be the inside walls of the camper as well, essentially, or like my inside space of how wide it feels like to me when I'm inside the camper. The truck length outer 62 inches, so this was from the cabin trim to essentially the tailgate, and like 1 or 2 inches into the tailgate. But the 62 inches is actually the measurement from the trim to the trim of that railing, like the trim rail of the sides, and where that ends. So I'm using that as my truck length outer. My cabin window width is 13 inches. I don't actually end up using this. And then my cabin to moonroof is 42 inches. So, quick spiel on OnShape before I move on to the rest of this video. I'm not sponsored. I just think that it's an awesome program, honestly. I don't think there's even a sponsorship to give. I just liked using their program. It's completely free. It's amazing for frames, especially when you're building something simple like this. Like, think building a shed, building, anything that basically the basic building block is a frame-like structure. So you can think of like 2x4s, aluminum extrusions, aluminum squares, tubing, whatever. As long as it's frame-like, OnShape handles it very, very well. I'm sure it also handles other CAD aspects well, but I've only really used this as a frames builder. This is my first time using it, and it was really easy to learn. There are definitely a few hiccups along the way, but it didn't take too long for me to get used to them, and then it didn't take long for me to find answers on their forums and online. So yeah, that's the quick spiel about OnShape. But basically, I took my truck dimensions, and then I have camper variables. So these are kind of my final dimensions that I use to build my camper frame, or what I will be using to build my camper frame. And this is the model that I use to order parts from Masumi, or aluminum extrusions from Masumi. So I have two extrusion size, a main extrusion size of 30 millimeters and an auxiliary extrusion size of 20 millimeters. So you'll see that I'm using millimeters here, and that's because my frames are being sourced from Masumi, and Masumi does millimeter cuts. And so it's very important that whether you're choosing a metric system or an imperial system for your frames, you need to make sure that the variables here reflect the kind of conditions of the supplier. So in this case, Masumi does millimeter cuts. They do them actually up to 0.5 millimeters in the request forms, but I just think that keeping them as whole numbers is better. So, and then the other supplier that I looked at was T-Nuts, and I'll talk about why after going through the CAD. So roof length is 104 inches. So I kind of chose this number. You can make this like a calculation. For instance, I have a slide out bed length, which determine how long that slide out bed section is. I chose 75 inches. That's because I'm 5'3". 75 inches is a full bed size, and this is going to be plenty enough room for me to feel comfortable. If I ever have any friends that wants to come camp with me, if they happen to be tall, I can accommodate people who are, you know, probably 6 feet. If they're 7 feet, too bad. But yeah. And then the roof length, this was kind of, I decided that my moon roof was 42 inches from the cabin, like the back of the cabin where the truck bed starts, and the truck bed length was 62 inches. So I just basically took the 62 plus the 42, and that was 104. Now this definitely could have been a calculated number, and in fact I can even change it to be the calculated number here instead of like a hard-coded one. I was just in debates for a while in terms of like, how long do I actually want the roof length to be? Do I want to ignore these constraints? Like, do I want to just make it as long as like what is reasonable? So like, for instance, like, you know, I could have made this 110 inches, which was one of the original designs, or I could have even got up to 120 inches, which would have been completely fine. Like, it would not be sticking out over the front of the truck at 120 inches. So there's a lot of leeway here in terms of picking the roof length, but I ended up picking what was essentially the truck length. So slide out bed, 75 inches. That's a full length bed size. Standing height is 78 inches. I once again kind of chose this number. This isn't, neither the standing height or the sitting height is important quite yet, just because I haven't finalized how I'm going to build the pop top. Eventually, one of these two dimensions will drive my pop top height. I think it will probably be the sitting height, just, but I don't think I'm actually 36 inches tall when I'm sitting. I'll need to get help measuring my sitting height. But I do also want a little bit of clearance, so that I can like stretch in bed when I'm like waking up and not bump my head, for instance. Camper width, so this is going to be the truck width inner plus the main extrusion size times 2 and then times 2. So I want the extrusion that's on the truck bed trim itself to be 2 extrusions wide, and then there's 2 of them on each side. So this, the overall camper width, that if you were to measure from outside of the camper, is going to be this dimension, which ends up being 1,644. Camper length, that's just our truck length in this case. Our camper height is the cabin height plus the cabin clearance, pretty straightforward. And then I have a small gap, which is 0.125 inches, and a medium gap, which is 0.25 inches. I'm going to skip the skin right now, mainly because I don't think it's that important, but it's just calculated off the camper width and then rounding back 2 inches, and that's because, once again, if I'm supplying ACM skin and asking for it to be pre-cut by manufacturers here in the Bay, most of them are working in the imperial system, which means back to inches. So I'm taking my widths here and I'm sealing them and then rounding them to the nearest 1/8 inch, because that's usually the accuracy of the cut that they can provide. Okay, so I'm going to go over how I designed the frame in OnShape as quickly as reasonable. The frame here, very straightforward. Building frames in OnShape is quite simple. You essentially make sketches and then the frames build around your sketch lines, or they can build around faces. So here, for example, I'm saying that, hey, I have this sketch. I want it to be, this is for the bottom part of the main body that is attaching to the truck. I want each of these pieces to be too wide. So I made my own 80/20 simple profile. And why I did this was because OnShape actually didn't have a extensive enough library for me to use. So they have an 80/20 library, and if, for instance, you were to use the main ones that other people use, you would have no problem using this. However, they didn't have things like With the 80/20 series, they have the 30 series, but they didn't have a 30x120, which is like a 1x4 extrusion like base. So I ended up just making my own, and I did that in another file. Alright, so this is my simple profile. I've made a configuration panel, and we'll look at the 1x1 here. So the sketch for the 1x1 is quite simple. It's a square. This is the extrusion size, and then for the 1x1 you just have an array of 1x1. I put 5 circles. This is so that I have the center, the sides like kind of like slots, and then there's a mate on the center of these sides, as well as like a mate in the center of the square. So this allows me to kind of just like create easy mates in the future. And yeah, so as you can see, I created this table to do configurations. So you can have like a 1x2 or a 1x3. You'll see that there is an extrusion size here, but this is not a configured list. This is a configured variable, which means that when you are asking OnShape to create the frame itself, you can tell it the variable numbers. So if I were to go and say, hey, I want this to be, I don't know, 60 millimeters, for instance, I can generate, and you can see now it widened, right? But we're not going to do that. We want our main extrusion size, and so these are my variables that I created from like the camper variables. I'm using a 2x1 for the shape, and then simple profile. Sometimes you might need to regenerate for it to reload. And why did that not load properly? Oh, because for some reason it didn't recognize that I chose the main extrusions. Oops. Sorry, sometimes it's confusing whether or not I need to click on something. Alright, so as you can see, very simple to modify. And I use my variables to basically drive the main body and then the roof, so that if I wanted to change the extrusions, I could, but this is kind of the final design that I actually purchase my extrusion from, so I'm not going to change anything right now. The other thing about making your own profile is that you'll have to tag it. Tagging it will allow you to put a description, and so otherwise like the name of these like shapes and the configuration doesn't come through on the frames itself. So by tagging it with a description, this description will show up in a bill of materials, and you'll see that in the end when I go through the frame. So very simple. This is on the truck bed, so you'll see I have the camper width, camper length, and if we look at the frame itself along with like the sketch, you'll see that the frame is nested, right? Which means that like this is the full length of the camper and the full width of the camper. And then as you can see that this here should be my 60 inches. So if I were to grab this and show you the measurement in inches, you'll see that it's 60 inches, and that's because of that driven variable where my camper width was my 60 inches plus. Since I'm using a 2 width extrusion, I'm doing 2 widths times 2, right, for my full camper width. And that was back in the variables. For the vertical members, I'm just, once again, I have another sketch. Like I said, I'm not using these numbers just yet, but I put them there as a visual. So I have my camper height, and then I have my 4 vertical extrusions. Next I have my bed height. So if I were to go in here, so this is where there's no, like, this is just based on the camper width divided by 2. That's mainly because I wanted 3 ribs. But this here is dictated by the roof length. So this is your overall, like, length of the outside for your camper. And yeah, now this is our main body. So you'll see I said that, hey, this is my main body. Basically, it's all these members here. They're all 30mm extrusions, and we can move on to the front axis door. So this is our first auxiliary component. The front axis door is entirely driven by just the gaps. So it's constrained by the camper body itself already. It has 2 ribs, but you'll see that there's 3 lines shown here. I just don't end up making this a frame member. And then the top is driven by a medium gap, and the sides is driven by a small gap. So the reason for the medium gap is so that I can fit a piano hinge right between the 2 frames, and then that will allow me to attach the 20mm to the 30mm, and then have an axis door that swings out and open. Yeah. So, and then yeah, you see that I have 2 ribs. The thinking behind that is that in the future, if I ever wanted to convert this into barn doors rather than an axis door, then I could cut this length in half with like just a miter saw, move these towards the center, and now suddenly I have 2 doors that I can put on some hinges here, and have a barn door operating without too much effort, hopefully. You know, things never go as planned, so. Alright, top of the slide out bed. So here, this is being dictated by my slide out bed length, and then I'm just adding an extra mean extrusion size. So even though this is being measured from the inside of the extrusion, and it should be the 75 inches, I just also thought I might put like some foam tape on the inside to help with insulation. Maybe there might be some plywood, I don't really know. I just wanted an extra buffer in case I wanted to, say, insulate the aluminum extrusion somehow from the bed area. That was one of my concerns. And then we have a small gap just to make sure that there's enough like leeway so that this slides in and out smoothly. And then 3 ribs. And then we have our last member, which is our roof. We're gonna hide our other members just so that it's easier to see. So this is our roof. It's also pretty straightforward. It has a rectangle completely constrained by the bottom part of the like camper, right? They're the exact same shape. So there's no measurements here. And then right now this is showing 5 ribs. None of this really matters just because they're not constrained. I'm not drilling holes along this beam in order to tie these in. I'm just connecting them with some inside connectors, and I can then freely place the beams as needed. So like if I have I will have a solar panel, for instance, at the front. I'll likely have I will have a fan at the back here. And I want to make sure that the ribs are not in the way of like any hole cuts that I might need to do for, say, wiring or for the fan cutout. So I just want to make sure I have 5. I actually ended up, I think, ordering 6 ribs just because I was just like, oh well, I like this 5 looks good. This looks quite evenly spaced. It's 17 inches at each rib, and overall I think it's like plenty of space, especially if I'm gonna do like a plywood deck with 3/4 ply. But because I wasn't quite sure how the ribs would lay with like the solar panel and with the fan, I wanted to just make sure that I had enough ribs at the ply area where I would be supporting human weight on the roof itself. So then we have our cutlass. So this is pretty straightforward. This is all of our extrusion that we have built so far. And the 30 series, is, as you saw, was just the main body. So if I click on this, it'll get highlighted. And then the 20 series is everything else. So that's your roof, your slide out bed, and the access door. And what's really awesome that OnShape does is it provides you a cut list. So this cut list, like I said, this description was not here until I added that tag. And I was just like, wait, how do I know what members are what extrusion size without having to actually look it up? So adding the tag allows me to easily say, okay, that was a 1x4, this is 2x2s, and you can see that when I click on these items, they'll highlight them and show you which piece it's referring to. There's the length, and then I've hidden them, but there's angles, but everything is 0 for me since there's no miter cuts. Yeah, so that is the frame, the profiles. So next time I'll talk about how I take this bill of materials from OnShape and create a list of materials to buy from Misumi and why I chose Misumi over T-Nuts. All right, see you next time.